create into math lesson 20.1, identify and classify polygons. I can identify and classify polygons. Spark your learning. Many of the figures found in art, nature, and science are familiar. Group the polygons shown based on two or more features or attributes they have in common. Okay, so we're going to draw a Venn diagram or a bubble map over a looping concept. Okay, so what are some things that we could possibly label these things? What do you guys see in some of those pictures?
Right angles.
Okay, so maybe something with a right angle, that would be one label we could have. What else? Oh, triangles. Okay, so you can do triangles. Okay, and then also, do some of those things have the same length?
Yes.
Yes, so we're going to draw the three bubbles. And then you guys see how they interloop over there? Okay, so it needs to be like that. Okay, where it kind of loops in the different spots. Okay, so we said triangles would be one of our labels. Okay, so that'll be this bubble right here. Okay, then we also have triangle or things, not necessarily triangles, but objects that have at least one right angle. That will be this bubble right there. And then we all said sides are all the same length. Okay, so they redrew the pictures. We're just going to number them. Okay, so we're going to call this 1, 2, 3, 4, 5, 6, 7, 8. Okay, so which ones are triangles? Okay, now of those, do any of them have all the same length? 5. Okay, so we're going to put that right here because it's a triangle and also has the same length. So we're going to put it in that overlapping one. Does that make sense? Okay. All right. So we've already used number 5. Okay. Let's see. And then we said what other 3 were triangles? 1, 2, and 4. Okay. So do any of those have at least one right angle? 4. So we're going to put it over here where that overlaps. Okay. And the other 2 triangles are just triangles, right? Okay, so 1 and 2. Let's leave that as a little bit bigger, better space so it doesn't look like it's number 12. So triangle 1 and triangle 2. Okay. Now, do we have any of the objects that have all the same length? 3 and 8. Okay, now do either one of those, are they a triangle or have at least one right side? This number 3. So that can go right in here, right? Okay, and then number 8 can come over here. Okay, so what 2 numbers are we left with then? 7 and 6. Okay, so do they have all the same size?
No.
7 does not have all the same sides, right? Okay, does it have at least one right angle? Yes, so, and it's not a triangle. So 7 could go here, then 6. Do the sides have all the same length? No. Do they have at least one right angle? Yep. Is it a triangle? No. So 6 would also go here as well. Build understanding number 1. Mr. Berger and his class are looking at the polygons shown. Record the attributes of different polygons in the table. Complete the the column for the figure that has 7 vertices. Okay, so name of the polygon is what? What's a 7-sided polygon? Hexagon. And we said it has 7 sides, 7 angles, and 7 vertices. So sides would be this right here, correct? Okay, angle would be this right here. Okay, and then vertices is what? What's a vertice?
Isn't it like a corner?
It's
Yeah,
where
it's
the two sides come to a point, right? So like these would be the vertices, right? Okay, a nonagon has what? How many sides? 9. Has 9 sides, 9 angles, and 9 vertices. Okay, so we can draw our own little picture for that. We can do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now could your picture look different than mine? Yes. Okay, basically we just wanted to have 9 sides, 9 angles, and 9 vertices. What are the little dots that I'm putting there? The vertices. Okay, all right. Okay, what else can we do? Could we do a pentagon? Okay, so pentagon. Basically, how are we knowing how many sides, angles, vertices we have? Well, because of their prefixes, right? Okay, so hepta means 7, nona means 9, penta means 5. Okay, so 5 sides, 5 angles, 5 vertices. Once again, does it have to be a particular shape?
No.
No, but just something with 5. So 1, 2, 3, 4, 5. Okay, what about a hexagon? So hexagon. So hexa means what? 6. So 6 sides, 6 angles, 6 vertices. And once again, it can be any type of shape, right? But most of the time we see it like this. Okay. All right, so what do you notice about the attributes of each polygon? What do you notice?
They all have
sides, angles, right. So for each shape, they all have the same number of sides, angles, and vertices, right? Okay. So the prefix hepta is Greek for the number 7. So heptagon is a polygon with 7 sides. The prefix nona is Latin for the number 9. So a nonagon is a polygon with 9 sides. That's what we just said just a little bit ago, right? Okay. The word congruent describes equal angle measures or equal side lengths in a figure. A regular polygon is a polygon in which all sides are congruent and all angles are congruent. So Mr. Berger drew these polygons on a whiteboard. What do you notice about the attributes of group 1?
they all have different sides.
Okay, so those are the shapes. They're not the same shapes, right? Okay, but both shapes individually each have what? The same amount of angles, same amount of sides, and vertices, right? And they are all equal or congruent, right? Okay, what do we notice about number 2 for group 2?
They have the same side as the first one, except they're just.
Are their angles the same measure? No, because if you notice here, this angle measure would be the same as this angle measure, right? But these are not the same angle measure, correct? Okay, and that's how it's usually denoted on shapes. Okay, usually they'll share like the same, like how I did one arc to show that those angles are congruent, okay? And then the other two would have two arcs saying that those two are congruent, okay? What about over here? These are probably congruent, right? And then these probably are not, because the ones with one mark are what angles? Obtuse angles, and the other ones are what? Acute, okay? Describe both groups of polygons using the words congruent and regular. Okay, so which ones would probably be regular polygons? Group 1 or group 2? Group 1, right? Because we said that they have all congruent sides, angles, right? Okay, and the same number of vertices, which group 2 has the same thing except for the angles are what? Different, okay? All right, chapter understanding number 1. Tam is cutting pieces of stained glass for a design. How would she determine whether the figures she cuts are regular polygons or not? So regular polygons, we said what?
They have
All the sides and what? And angles are congruent. Okay, on your own, you will do this whole page, so if the recording runs out, it will still need to all be completed. Number 2, use structure. Honeycombs use the repeated shape of one type of polygon. Identify this polygon and the number of its sides, angles, and vertices. How does knowing any of one of these help you know the other 3? Okay, so what shape is that? It's a hexagon. Because what? Because there are 6 sides, angles, and what? And vertices. Okay, so when we look at it, we can tell that there's 6 sides, right off the bat, and then we can also tell that they're what? Congruent as well. Okay, and then that also helps us then figure out the angles and vertices. In the polygon, tell whether it is regular polygon or not a regular polygon. Okay, so what's that first one? How many sides does it have? 9, right? So it's a nonagon. Then is it regular or not regular? Regular. And why is it regular? Because each side has one little tack mark, right? And there's not any with 2 or 3, right? Meaning that they're all congruent. And then all the angles have one arc, right? And there's not any that have 2 or 3, which means they're all congruent. So it's regular. Okay, and then they want to know the number of sides, and we said times the sides. Okay, next one. What is it? Triangle. That has how many sides? 3 sides. Okay. Then, is it regular or not regular? Not regular, because a couple of them have one tack mark. Another one has 2, which means those sides are not congruent, right? Angles, this one has one arc, but then that has a 90 degrees, so that means they're not congruent. So not regular. And then how many sides? 3 sides. So you need to make sure when you're doing these problems today, you pay attention to what they're all asking for, because there might be multiple things. Number 5, use tools. Kim connects 7 of the dots on the paper. She says the figure has 7 sides, so she has drawn a hexagon. Is she correct? Explain. So she has 1, 2, 3, 4, 5, 6, 7. She only drew 7. But is her thing a shape?
No.
No, because it's